be live to check my stream on another device. The latency. Yeah, I don't know what the latency is. Yep, it's pretty slow. Couple, like 4 or 5 seconds or so. Me just quickly. Let me just start Zoom as well, just in case. Sorry for that. Yeah, no BS. I need to start my virtual camera and recording to my computer as well. And streaming. It's all working okay. I haven't lost any frames yet. At the Zoom link if anyone wants to join live. So we normally quickly test the site. It would be really good to see someone else using it, not only myself. This full screen at 90%. I don't know why. See a tiny bit of something else there. Now it's gone. Just 100% wait. What the? Yeah, it is Firefox. It should be optimized when I'm in full screen, but it isn't. I don't know what happened to that. And check another tool. And this is the last one we added, so this one looks okay. And why don't we have the text here that we generated using a large language model? Well, that's because we haven't published the website since. So I'll probably do it at the end of the stream. There should be some text description that essentially asked one of the GPTs to describe what's on the page. So that should be there. This screen fits nicely. What size is it at? I'm in full screen so I can see it. Yes, so this one, 100%. Well, it fits well onto my screen, which is nice. I don't know how it will work for you. But there's still some white spaces on left and right. Could later use it for advertisement. No, hopefully not. Just joking. We don't want too many ads. I'm using an ad blocker in Firefox, so I don't see any ads. Get out of full screen for a sec. Just as a side note, this is a consulting page. Please let me know if you need the sample username and password if you would like to try it out. It is a work in progress. Let me refresh this one quickly on another page. I might do it later offline. It's okay, I'll just close it for now. So essentially, it's will be tools like this. One of the things we said we might do is remove the play button because it's a bit just a tick too heavy for my server, especially if you have multiple of them open. And potentially you just like forget to turn it off. In theory, the page should time out after a certain period of time, but I haven't tested it, so I might just remove it entirely. And again, if you need this option, I could potentially bring it back on Bunny Cloud, which will require a registration, like a username and password. So essentially, you'll see the same thing. You will come to this page, log in, and see the same thing. It's not ideal. Ideally, we don't have to do this, but we'll just see how we go. Same with this did noise. There's only a couple of tools that have the play button. This one also doesn't fit the screen in 100%. Even this is 100%, this is full screen. Pretty sure I originally decided to fit, but it doesn't. It actually, this one actually has two lines of control. So I have to watch which one's which. This one has some text in it. We will generate some more. The logo was way too large to adjust those. Yeah, this one just fits. Okay. The white spaces on the edges of the screen. Try fixing that probably sometime later. Haven't tested this one for a while. This one also. So this one has the file scroll, but no play button. And there's this free displays, and they do fit in nicely. And again, this one will need more text, more description. It's not really for anyone to read. It's really for um, search engine crawlers to actually know what the page is all about. So I was using a large language models to generate some of the text. Just close a few things. And yes, eventually we already started. I started using. I don't know why I say we. I keep saying we. I started using ChatGPT to generate some Python script. So I don't know if it will actually work. Have to install Flask. I think that's to actually span out the website. Hopefully, you will have access to all the HTML as well. Well, obviously, you should. And then we ask it to generate the web page with a graph, and it also did that. I don't know if it will actually work. Obviously, if I just copy paste it as is, I don't think I have Flask installed. Can try it out. We already have it open. And do we need a new? Um, a new file, so call it HTML a graph should be dot y. Um, this button works. Can I just copy the code? And of course, I get an error message for Flask. Need to pip install Flask, and it never worked for me because to do it from the PowerShell, but I'm in the wrong terminal. Um, Sorry, in the wrong folder. I had to run the pip command. So I'm jumping around, but that's why this channel is called the Body Chaos, because it's chaos as everything is. Pretty sure if I run this, need to be in the right folder. Where's my pip folder? Um, so it's wherever Python is installed, isn't it? The Copilot wouldn't work. No, you have to pay for it or something. Missing a token. I can't use it from here. That's why I'm using a standalone ChatGPT. Before it was giving me a poem about the EEG data processing. Yeah, let's put it mildly. It's not great, but if you can make it better. Some parts are not too bad. Yeah, it sounds a bit childish to me. I still don't know what this. This is when regenerating response. Alright, you can actually scroll through it, so it made it shorter in the realm of mind's electric sea, e.g. data dances wild and free. uh, from brainwaves rhythm insights arise, unveiling the language of neural skies. uh, this one's pretty bad. Know how that thing works. Like when you regenerate the to keep remember the previous thing. Still searching for my Python install. How do you check it in here? Reload required. Why? This publisher is verified ownership of GitHub. The extension is enabled globally. Please reload Visual Studio Code to enable the updated extension. Well, it doesn't work. Anyways, no, I don't use Git for Windows. Run Python file, debug Python file, debug console. Just looking for outline. No extensions. So this Python thing. I mean, it's already. Right, yeah. I have two versions installed. Wanna find its. Oops. Oh, come on. What? Bit buggy. Yeah, just one there. Yeah, how do I go to that folder in the terminal in the PowerShell? Right, local. Found the folder. So we're using the 311 one. And I forgot where the in scripts. Yep, the pip. Right. And now we can right. Pip's not recognized. F pip 3. That folder scripts. problem. How to run a peep. What's it called? Forget. In Visual Studio. See your project. I suspect I'm in the project. Open the Python environment you're working with. You can do this by going to the Python environments window. It should be this. View. The Python environments menu, you will see a list of installed Python environments. Select the one you want. 3.2, yeah, that's the one. 3.11. Select the packages. See packages. Tab in the Python environments window. Yes. Oh, there's a gazillion of them. Once you have selected environment packages, tab in the Python environments window. In the packages tab, instead of search box, type the name of the package you want to install in the search box. The search box. The peep is already been installed SciPy. I mean, in Python environments, select environments, see packages tab on the Python environments window. Yes. But right, terminal. keeps adding more options. Right. Right. So it does work. That's great. We were running the first a web page with Python, and let's do something more complicated. So now the flask is not highlighted, which is good. Copy code. Now we'll have matplotlib terminal. Oh wait, PowerShell. We'll do the same thing. Install matplotlib. And find version. Why is it? Wait, import my SPLT. This example creates simple power. You see the graph displayed. Running. Wanting this development server. Control C to quit. Ah, every time. Right, every time we refresh that page, we get this. And if we press Control C, it doesn't work anymore. Okay. And this one is giving me an error. In PowerShell. Oops. Okay. It's a regular terminal, isn't it? Right. Now it's downloading matplotlib. Starting with directories. I have to redo all this later if that works. Let's install something else. Apply. Right, that underline went away. Development server, internal server, server encountered internal error and was unable to complete your request. Either the service offloaded. What? There's an error in the application. So give me response 500. Development server. Does it use for production? Okay. User warning. Starting MATLAB GUI outside of main thread will likely fail. Error in app. Line 14. Plot. So how do I debug this thing? Like when it's plotting? Uh, Create a plot. Something with Flask. Yeah, this one. Okay. Could have. I was trying to get this bot to run. I would like to run anything in our browser because I have the text to speech thing. With this this other chatbot that generate Python. Generating code, but it looks like this, really weird. Let's cut off as well. This will regenerate it. Be the same thing. It looks the same. It's still running. Wait, it's actually different. Main thread's not in the main loop. What? Can we use what? Just using another plotting thing. Plotly. Plotly as well. Server. Ah, yeah, now it's stopped running. Just come back in a second. Sorry for that. Let's keep going. So where's the render template? Generating this HTML. Control press. Server. Error. Error in app. Drag back. A template not found. Index HTML. What's this? Ginger. 2 exceptions. Template not found. Graph. In this template we include Plotly JavaScript library element with an ID graph. We use Ginger templating to inject the graph HTML generated in Python code into this. Wait a second. So this should be okay. I haven't finished the whole thing, did I? Helps. The previous thing also tell me to. Yes, it did. I have to actually create a HTML file. That would be useful, isn't it? So we need to create necessary libraries. Yes, home function to generate the sample data. Plotly create the line graph using that data. So did it? Is it still running or? Right, no, it's still running because I'm getting those requests. I'm getting a 500 error. Customize the graph by setting the title. Yes. And we convert to HTML. False HTML false for some reason. Okay. We'll configure the, then we convert the graph to HTML using the HTML method plotly figure object. Finally, we render the template. One join name. If you like, you can ask a question here in the YouTube channel, or there's also a link to Zoom if you want to join in for a live chat. But what we're trying to do is just generate a basic HTML in Python, and we have a server, like a Python server running just locally. It's meant to display a graph, but I haven't completed it because I also need to generate, I think I need to create a HTML file. So to render the template called index.html. This index.html is not automatically created, of course, and pass the graph.html to it as a variable called graph.html. So it's this one here. We can create the index.html in the same directory, right? So we need to create the index.html new file index.html. Put it in the same directory for now. This director was actually doing something else, was actually um, checking my website every 5 minutes. Python script and include the following code, so we can copy the code into here. Will be title JavaScript file. One code. In this template, we include a Plotly JavaScript library and create a div element graph. We use the Jinja templating to inject the graph HTML generating Python code in this div. So that would be that graph. When you run the Python script, visit browser. So we have to save this. We have the Python script and we need to run it again. We're getting these errors. Let's run it again, which is the close it, Control C. Run this again and Control click, and we have an error. We have Flask and Plotly installed. We still get that 500. Dun, 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 dun. Okay, now I'm stuck. If anyone can help, that would be great. How come it cannot find? Getting 500. I think of that ginger. Lighting pie. Encountering index error means that Flask is unable to find the index HTML template file in the expected location. To resolve this issue, make sure that the index file is located in the folder named templates. What? All right. Templates index. Yes. Templates. Okay. A Control C and run again. And it's working. Yes, we have our first graph in Python. Thank you Who do we have to thank? Well, I guess mainly ChatGPT because it wrote the whole script. Yeah, we had just a folder issue with Ginger not being able to find the index HTML file. And these numbers here place in 14 or something. Uh, yeah, now the question is like how to get it, have to stop it. If you want to change something in it, that would be next stage, isn't it? By the way, if you want to join in the live chat, this is also on Zoom. There's a link in the chat. Um, right, so this one was changed. Previous one still the same. So if I refresh, yeah. So that's nice. And we add a bar chart and send it. So the good thing is also explains the code as well. Yeah, help me. It did help me to resolve an error. Yeah, my Copilot within Visual Studio doesn't work. I think. I was just trying to use it before, and it will come up with an error message. Yeah, so there are multiple questions that we need to resolve. Well, first, yeah, we need to make it more complicated, but that's doable. Also, do I then need to have this always running? How do I change the port? I'd like to change the port number. Don't like the 5000. No, I could use the 5000. I have to open that port on my server if I want to publish anything for it to be accessible. So that's nice. And then with this code, how do I generate with a graph? So what if I oop, with a graph, line graph, and what's it? Bar chart. Right, that's nice. And it's still using. Now it's using Matplotlib, whereas before it was using Plotly. Plot. I don't know how to pronounce it. I don't think there's a way to properly pronounce it, is it? Well, we wanna keep this one with the index. Right, it will have two images. Wait, so is this a graph? Because this is not an image. This one is a graph. You can hover, and do this, which is nice. Can download plot. Does it zoom in? Pen box select. This one should, yeah, reset. Produced by Plotly JavaScript. Okay, fair enough. Assume it's still open source. But yeah, long story short, yeah, this is pretty exciting. Yeah, I might generate another HTML with a different name. Yeah, interestingly, it's sometimes it's deciding to use Plotly and another time matplotlib. Can I file, new file, line, line plot, and bar chart. Why? No, how does it deal with spaces? Does it also doesn't like spaces like Leview didn't like spaces when you generate the get request. So this one is also using, yeah, get request HTTP 1.1. Yeah, I should be able to host this, make it accessible, make more interesting tools to get off the Leview. We generated now one of those. Uh, place it in the main folder. Copy this code, which fair enough it's able to also explain. But then the HTML file should be different. We want a different name. So we want to create another how do we do that? Index to HTML. We copy this into that to save it all. Now this is index 2. Was the other question is like, can they both run together? This one is still running, is it? Where is it? This one's still alive. Yeah, every time you refresh the page, you get this, which is nice. You can store it. Yesterday, someone was Tony was asking, saying something about yeah, keeping track record of this thing. So yeah, that's pretty much all you get. You get like an IP address, date, time, and what command was used. And no, you won't get. Yeah, I was wondering if you get anything for this one for. Uh, how do you get rid of it? Go away. Right. No, it's just sitting there now. It's a bit funny. Just leave it there for now. check OBS again. If anyone wants to join in, jump onto Zoom, have a chat. That would be nice. I always have much better streams, live streams, and potential videos if I'm actually chatting to someone, not not just the chatbot. Soulless, cold machine, heartless machine. So let's see, where were we? So we had that index 2. We have another Python script. This one then need to change to index 2. Save there. Try running it. So how? Why am I'm not able just to run them together? Anyone knows? See, sounds like I have to kill this one, run that one, get a debugger pin is active. What? Right, those are images and they don't work. I get a 404. Okay. Well, first, the what is it? The Plotly is actually working better. So, can I do the same? Where is it? Using Plotly, can edit it using. I think it's obvious that we're doing Python. What's called Plotly? Right, generating something. And yeah, you can go back to what it generated before. So essentially, I regenerate this sentence or this prompt four times. Right, so now we're using Plotly, same thing. And where's our HTML? Don't tell me I have to write it myself. Um, oh, I don't need it. So here's okay. Plotly, yes. Values, bar values, yes. Okay, just same, but different. A figure. So you have this. You're adding things to a figure and writing HTML. Right. So it's so you potentially do not need the HTML file anymore, which is great. In this example, we use Plotly graph object module, create the graph and bar chart, make subplots, blah blah blah. Address, that's okay. After running the script, you will find HTML. Okay. Need to stop that one, I guess. Run this one. Debug is active. Getting a 404. Did it generate a HTML? Where? Um, where is it? So when we well, An error. A Control C. Try running it again for a sec. Bug on this mode is on. Oh, come on. Can I just kill it from here? Right. Starting this down. It's running. Debugging is more warning. The development. Yes, do not use for production. Okay. Uh, do not use for production. That's okay. Problem is, does work. No proper error message. Just this funny bit. Just put in my other screen. So what is where you can modify the code explicitly specifying a non-GUI backend for matplotlib. Here's an updated version of the script. What? So I have to get rid of that one. Would it have been easy if it generated the whole thing? Don't care, just generate the whole thing. But did it have enough? Had enough? Outside of the main thread. But this one worked. This is Plotly graph object is go. Plot is plt graph object. Render template. What's it doing? Ah, is it? It would not do it again, is it? Something went wrong. The HTTP please connect. Blah blah. Try. No, it's 6 out of 6. Right. What's the difference? So I guess the Copilot will actually show you what the changes were made and things like that. Address. Offline. Just creating new names. Offline plot. Where's the bit to generate the HTML out of it? When you run the script, it will generate HTML file named chart.html in the current directory. Yeah, well, this one doesn't work, so let's go this. Right, generated them. Yes, those are not the images. Generated something that's good on the same. Because yeah, I was kind of expecting it to do as before on separate charts, but this is executable, so that's good. Bar trace. With separate. But this one is a keeper. Right, yeah, now it's doing. Yeah, that's nice. To know what it's doing. Okay, 1 to 5, and then random numbers. Yeah, it's generating the HTML within the same code. Interestingly, this one is it generated its own HTML. So it's not actually published or anything. Like, it's just loading the HTML. That one is interesting. Create the new. This should be. Oops. A new file. Let that by. Hopefully spaces are okay. Create file, yes. Copy file. Mention. Set the script files. and execute it. Yeah, so that previous code just executed once. It's not actually running. So you can't keep calling. It's just generating HTML, which is good. That's actually what I need. I'll be hosting it myself. Yeah, that's more like it. I like it. I like it. This one, very nice. Very nice. So this one's actually generating a server, actually being hosted. Uh, but I'll need it as a, yeah, HTML file would not be bad. Well, what do I then? You can try it on Bionic Cloud or something, but no, I want it on Bionic Chaos, right? Zooming in both. Both plots PNG, that's nice. Can you add era? Whiskers, like arrow bars, arrow, what's it called? Um, bar chart. Um, Error indicators in Plotly. Get the plots. With error margins. Create the no one. And we can control C this. Start a new one. Oops. A new file. Apply. Yes, same folder. Import Plotly. Yes, graph objects. From Plotly, subplots import makes plots. This is nice that it's actually putting in annotations before. Ah, no, we had them as well. That's really good. Yes, some random numbers, arrow lines. That's nice. So that would be for the Right, it's doing it both for the line graph and bar chart. Yep. Um, two subplots are in one figure. You have subplots as well. Head trace. And returning this HTML. Network. Uh, network error. It's not my network error, is it? It's still live. Yes, yes. That's much quicker. What? Wasn't using pandas before. It's crazy. Like every time it will give you like a different thing. So create a HTML. Okay. Graph HTML. Pandas. Okay. Do you need pandas? Pandas. We need pandas. Yes. About to be in that folder. That is nice, but why can't you just see the variables? Where's my folder? Python. So if I'm oh, scripts, VP, that scripts, install pandas. Right, that's working. So yeah, you do need to be in the right folder, and I don't know how to install it from here. That's yes. New release of Beep. I don't think it does matter. So, so we have pandas. Oh, did it do anything? Uh, close this. Run it again. Make this large. Just see what's the problem is. Error. Y color. What? Trace back. Most recent call. Type pair bar. Got an unexpected keyword argument. Type pair. Will it fix this here? Apologize, blah blah. Is it regenerating the whole thing? Looks like. Close this while it's doing it. I can leave the terminal with the scripts. Yeah, we have the errors. Why do we only have why do we only seem to have one? Let's give it a try. The generated graph HTML. Oh, license and the MIT license. Open with what? Copy path into browser. I'm just closing a few things. Right. Nice. Nice. Same. They're related or different? Didn't last for separate. That's pretty good. I assume you can change the colors and the like. Anyway, we'll continue on this one next week. But it's pretty looks very promising. Thank you, ChatGPT. Should make you a co-host of my YouTube channel. Would you like to be a co-host or a host of my YouTube channel? Will have the ability to physically participate. What? As a text based. However, I'm here to help. Okay. Uh, we might leave it at that. Had to post a few things on. We haven't actually finished testing, and we wanted to just say goodbye, see you next time. I'll just keep doing this. Get out of full screen. Yeah, we had an update both for Bionic and Bionic Cloud. For Bionic Chaos, we were generating some text. We have here, and say various large language models were used to generate the above text. They should go online soon. This one has it as well. It, yeah, the auto sizing here is funny. So say spectrogram. HTML. This, can I HTML do it like a get? Yeah, within HTML, we need the get request. Yeah, we can ask ChatGPT to do that. So I was using another actually chatbot for generating some text in here. I was using that one because it's optimized for well, supposedly medical stuff tailored towards up here it's called clinical camel. Let's show what the camel means, um, and why do they call it clinical considering there's nothing clinical about it. But anyhow, I was wanted to generate text with no frequency spectrogram or EG review. Don't need that. Frequency bands. And different frequency bands over time window. Can get rid of all that. This some this chatbot actually you can change parameters and things, but I'll just leave it as default. Run this for a sec. That's the spectrogram chat proxy. I was trying to last time couldn't get it to work. We're trying to in my OBS. This one does say chat proxy. The good thing about using the Microsoft thing is that it has a built-in. No, you can't hear that. Application. Or why do I have it as Explorer and Microsoft Edge?
Context of EEG review. A frequency spectrogram would be used to analyze the power spectral density of the EEG signal over a certain time window. Different frequency bands in the frequency spectrogram for EEG review refer to different frequency ranges that are of interest for the analysis. For example, the frequency bands used in EEG analysis often include delta, 0.5 to 4 Hz, theta, 4 to 8 Hz, alpha, 8 to 12 Hz, beta, 12 to 30 Hz, and gamma, greater than 30 Hz. By analyzing the power spectral density of the EEG signal in each of these frequency bands over a certain time window, researchers can gain insights into the neural activity that is occurring in the brain during that time window. The time window for the frequency spectrogram is the period of time over which the analysis is performed. This can range from a few seconds to several minutes or even longer, depending on the specific research question and experimental design. The frequency spectrogram can be updated in real time as new data is collected, allowing researchers to track changes in neural activity over time. Overall, frequency spectrograms for EEG review are a powerful tool for analyzing neural activity in the brain and can provide insights into a wide range of cognitive processes, including attention, memory, and language.
So, okay. I want it to be probably shorter. I'm not talking about power spectral density. Can you tell it like what not to include? How many? Let's see if we regenerate it, if the spectral density goes away, just by chance. Yeah, the first sentence is fine.
A frequency spectrogram is a visual representation of the power spectrum of a signal as a function of time and frequency. In the context of EEG review, a frequency spectrogram would be used to analyze the power of different frequency bands in the EEG signal over a specific time window. The x-axis of the frequency spectrogram represents time, typically in seconds or milliseconds, while the y-axis represents frequency, typically in hertz. Each color or shade of color in the plot represents the power of a specific frequency band, with darker colors indicating higher power and lighter colors indicating lower power. Frequency spectrograms are commonly used in EEG analysis to identify changes in the power of specific frequency bands over time. For example, changes in the power of the alpha, beta, theta, and delta bands are often used as indicators of different cognitive states, such as wakefulness, drowsiness, and sleep. In conclusion, a frequency spectrogram is a useful tool for EEG analysis, as it allows researchers and clinicians to visualize and analyze the power of different frequency bands in the EEG signal over time, which can provide valuable insights into cognitive states and brain activity.
Okay, let's put a couple of keep a couple of those. That's what we did previously. And we were changing the parameters. Well, I'd probably make it a bit shorter and the temperature in half. Yesterday we were trying to guess what the temperature is, and it's probably like how authoritative the text sounds.
A frequency spectrogram is a visual representation of the power spectrum of a signal as a function of time and frequency. In the context of EEG review, a frequency spectrogram would show the power distribution of the EEG signal across different frequency bands over a specified time window. The frequency bands used in EEG analysis typically include delta, theta, alpha, beta, and gamma. Delta waves, 0.5 to 4 Hz, are the lowest frequency brain waves and are associated with deep sleep and unconsciousness. Theta waves, 4 to 8 Hz, are associated with relaxation and daydreaming. Alpha waves, 8 to 12 Hz, are associated with relaxed wakefulness and the relaxation response. Beta waves, 12 to 30 Hz, are associated with active thinking and problem solving, while gamma waves, 30 to 100 Hz, are associated with cognitive processing and attention. A frequency spectrogram for EEG review would show the power distribution of the EEG signal across these different frequency bands over a specified time window. This can help researchers and clinicians identify changes in brain activity that may be associated with specific cognitive or physiological processes, such as sleep, attention, or memory. Send.
Right, all that. Yeah, I have to get rid of the yeah, this one is actually not covering frequency bands. I wanted to cover the overlay option. Probably it's not very relevant. General settings, window size. Yeah, we actually had to have more relevant settings to the spectrogram specifically. Those are actually time domain settings. Just do this shorter one. Too long.
A frequency spectrogram for EEG review over a time window would show the power distribution of the EEG signal across different frequency bands over a specified period of time. This can help researchers and clinicians identify changes in brain activity that may be associated with specific cognitive or physiological processes, such as sleep, attention, or memory. For example, a frequency spectrogram may show that during a period of deep sleep, there is an increase in delta wave activity, indicating that the brain is in a state of deep relaxation. During a period of active thinking or problem solving, there may be an increase in beta wave activity, indicating that the brain is engaged in cognitive processing. Frequency spectrograms can also be used to compare brain activity between different conditions or states, such as between a resting state and a task-performing state. By comparing the power distribution of the EEG signal across different frequency bands, researchers and clinicians can gain insights into the underlying neural processes that are associated with specific cognitive or physiological phenomena.
Right. Yes, I'll save this one for now because that's what we have. But the same. If we get the time window, but we want to add the epilepsy. Makes any difference? It just takes tokens, doesn't it?
Frequency spectrogram for EEG review in epilepsy would show the power distribution of the EEG signal across different frequency bands over a specified time window in patients with epilepsy. This can help clinicians and researchers identify changes in brain activity that may be associated with seizures or epileptic activity. In patients with epilepsy, seizures can be associated with specific patterns of brain activity, including increases in certain frequency bands and decreases in others. By analyzing frequency spectrograms, clinicians and researchers can identify these patterns and potentially use them to diagnose or classify different types of epilepsy, as well as to monitor treatment efficacy and seizure frequency. For example, a frequency spectrogram may show that during a seizure, there is an increase in the power of beta and gamma waves, indicating that the brain is engaged in highly active and synchronized neural processing. In contrast, during a period of normal wakefulness, there may be an increase in the power of alpha and theta waves, indicating that the brain is more relaxed and less engaged in cognitive processing. Frequency spectrograms can also be used to compare brain activity between different types of epilepsy or between different stages of a seizure. By comparing the power distribution of the EEG signal across different frequency bands, clinicians and researchers can gain insights into the underlying neural processes that are associated with epileptic activity and potentially develop more. Send.
Just cut off. Keep that one for now because we don't have anything else, but let's regenerate it. Just change the settings a bit. I haven't actually tried this top B. I don't know what that does. Save complete.
A frequency spectrogram for EEG review in epilepsy would show the power distribution of the EEG signal across different frequency bands over a specified time window in individuals with epilepsy. This can help clinicians and researchers identify changes in brain activity that may be associated with seizures or epileptic activity. In individuals with epilepsy, the frequency spectrogram may show an increase in abnormal brain activity, such as excessive beta or gamma wave activity, in the period leading up to a seizure. This increased activity may be associated with an increased likelihood of seizure occurrence. The frequency spectrogram may also show changes in brain activity during different types of seizures. For example, the spectrogram may show an increase in theta wave activity during absence seizures or delta wave activity during generalized tonic-clonic seizures. By analyzing the frequency spectrogram for EEG review in epilepsy, clinicians and researchers can gain insights into the underlying neural processes that are associated with epileptic activity and seizures. This can help inform treatment decisions and improve outcomes for individuals with epilepsy.
Yeah, it's hard to tell, but I'm pretty sure it's better than the previous one. Just generate a couple, 2 or 3 times, see if it's getting any better or worse.
A frequency spectrogram for EEG review in epilepsy would show the power distribution of the EEG signal across different frequency bands over a specified time window in patients with epilepsy. This can help clinicians and researchers identify changes in brain activity that may be associated with seizures or epileptic activity. In patients with epilepsy, the frequency spectrogram may show an increase in the power of certain frequency bands, such as the beta band, during seizures or other epileptic activity. This increase in beta wave activity may be associated with increased neural activity and synchrony in the brain, which is thought to be related to the generation and propagation of seizures. Frequency spectrograms can also be used to compare brain activity between different types of epilepsy or between epileptic and non-epileptic patients. By comparing the power distribution of the EEG signal across different frequency bands, clinicians and researchers can gain insights into the underlying neural processes that are associated with specific types of epilepsy or epileptic activity. Overall, frequency spectrograms for EEG review are an important tool for understanding the neural mechanisms of epilepsy and for developing more effective diagnostic and treatment strategies for this complex neurological disorder.
This just feels a bit better. Let's just do it once more. 8. Why do I have it a bit shorter?
A frequency spectrogram for EEG review in epilepsy would show the power distribution of the EEG signal across different frequency bands over a specified time window in patients with epilepsy. This can help neurologists and epileptologists identify changes in brain activity that may be associated with seizures or epileptic activity. In patients with epilepsy, the frequency spectrogram may show an increase in the power of certain frequency bands, such as theta or beta waves, during seizures or other epileptic activity. This increase in power may be associated with specific seizure types or epileptic syndromes. Frequency spectrograms can also be used to compare brain activity between different patients with epilepsy or between patients with epilepsy and healthy controls. By comparing the power distribution of the EEG signal across different frequency bands, neurologists and epileptologists can gain insights into the underlying neural processes that are associated with epileptic activity and seizures. In addition, frequency spectrograms can be used to evaluate the effectiveness of different treatments for epilepsy, such as medications or surgery. By comparing the power distribution of the EEG signal before and after treatment, neurologists and epileptologists can assess whether the treatment is effectively reducing seizure activity or epileptic activity.
Yeah, that one's too much. The new one is not better than the previous ones. Just get rid of it. Like this one is shorter.
A frequency spectrogram for EEG review in epilepsy would show the power distribution of the EEG signal across different frequency bands over a specified time window in patients with epilepsy. This can help neurologists and epileptologists identify changes in brain activity that may be associated with seizures or epileptic activity. In patients with epilepsy, the frequency spectrogram may show an increase in the power of certain frequency bands, such as the beta band, during seizures or interictal epileptiform discharges. This increase in beta wave activity may be associated with increased neural activity and excitability, which can lead to seizures. By analyzing the frequency spectrogram, neurologists and epileptologists can gain insights into the underlying neural processes that are associated with epileptic activity.
Yeah, the previous one is still better. So modified couple. Can we put it into ChatGPT for a summary? Make it shorter. That was like 4 paragraphs. This is still 4 paragraphs. So I need to place it into
Activity. This can help them to better understand the mechanism. Send. Thumb. Thumb. Warning flag.
I did summarize.
Frequency spectrograms in EEG review are a valuable tool for understanding the neural mechanisms underlying epilepsy and for developing more effective diagnostic and treatment strategies for this condition. By analyzing the power distribution of the EEG signal across different frequency bands within a specified time window, clinicians and researchers can identify changes in brain activity that may be associated with seizures or epileptic activity. This can help them to better understand the underlying neural processes that are associated with particular epilepsy types or epileptic activity patterns and to develop more effective treatments for the condition.
Right. That's pretty much the same. We changed it a bit. We need that sentence because we were using multiple models. Oh, stop that. This for a spectrogram. Yeah, various LLMs were used to generate the above text. Just check something. Yeah, why is that? Yeah, this one we have for the image, number of bits, type of wavelet. Not just for some reason. This one's okay. Spectrogram is okay. One was only 4 sentences or something. Just too quickly. Quick, we're running out of time. 2 hours in this stream. Just want to just leave it as is because we already checked it before. Generate something for a lot.
There are several types of signal noise that can affect the quality and accuracy of signals, including uniform white noise, Gaussian white noise, periodic noise, and inverse F noise. Here is a brief comparison of these types of noise. Uniform white noise. Uniform white noise is a type of noise that has equal power across all frequency bands. It is characterized by a flat power spectrum and is often used as a model for random noise in signal processing applications. Uniform white noise can cause problems in signal processing by obscuring important signal features and making it difficult to distinguish between noise and signal. Gaussian white noise. Gaussian white noise is a type of noise that has a power spectrum that follows a Gaussian distribution. It is characterized by a bell-shaped curve and has equal power across all frequency bands. Gaussian white noise is often used as a model for random noise in signal processing applications and is similar to uniform white noise in terms of its effect on signal processing. Periodic noise. Periodic noise is a type of noise that has a repetitive pattern and is characterized by a periodic power spectrum. It is often caused by mechanical or electrical vibrations and can cause problems in signal processing by obscuring important signal features and making it difficult to distinguish between noise and signal. Inverse F noise. Inverse F noise is a type of noise that has a power spectrum that is the inverse of the frequency. It is characterized by a high-frequency noise component and is often caused by electronic noise in circuits. Inverse F noise can cause problems in signal processing by obscuring important signal features and making it difficult to distinguish between noise and signal. In summary, all of these types of noise can affect the quality and accuracy of signals, but they have different characteristics and effects on signal processing. Uniform white noise and Gaussian white noise are similar in their effects on signal processing, while periodic noise and inverse F noise have different characteristics and effects due to their repetitive patterns. Inverse F noise is a type of noise that is often encountered in electroencephalography (EEG) recordings. It is characterized by a high-frequency noise component that is the inverse of the frequency, meaning that it has a higher amplitude at high frequencies and a lower amplitude at low frequencies. Inverse F noise can cause problems in EEG signal processing by obscuring important brain activity features and making it difficult to distinguish between noise and signal. It can also contribute to the overall noise level in the EEG signal, which can affect the accuracy of EEG-based diagnostic and research applications. To reduce the impact of inverse F noise in EEG recordings, various techniques can be used, such as bandpass filtering, adaptive filtering, and signal averaging. These techniques can help to remove or reduce the high-frequency noise component and improve the quality of the EEG signal. In summary, inverse F noise is a type of noise that can affect the quality and accuracy of EEG signals, but various techniques can be used to reduce its impact and improve the overall quality of the EEG signal. In EEG, different types of signal noise can affect the quality and accuracy of the recorded signals. These types of noise include uniform white noise, Gaussian white noise, periodic noise, and inverse F noise. Uniform white noise. Uniform white noise is a type of noise that has equal power across all frequency bands. It is characterized by a flat power spectrum and is often used as a model for random noise in signal processing applications. Uniform white noise can cause problems in EEG signal processing by obscuring important brain activity features and making it difficult to distinguish between noise and signal. Gaussian white noise. Gaussian white noise is a type of noise that has a power spectrum that follows a Gaussian distribution. It is characterized by a bell-shaped curve and has equal power across all frequency bands. Gaussian white noise is often used as a model for random noise in signal processing applications and is similar to uniform white noise in terms of its effect on EEG signal processing. Periodic noise. Periodic noise is a type of noise that has a repetitive pattern and is characterized by a periodic power spectrum. It is often caused by mechanical or electrical vibrations and can cause problems in EEG signal processing by obscuring important brain activity features and making it difficult to distinguish between noise and signal. Inverse F noise. Inverse F noise is a type of noise that has a power spectrum that is the inverse of the frequency. It is characterized by a high-frequency noise component and is often caused by electronic noise in circuits. Inverse F noise can cause problems in EEG signal processing by obscuring important brain activity features and making it difficult to distinguish between noise and signal.
It's not specific to this last prompt on the original settings. Those are the default settings, and we wanted to generate this. I suspect this is much better.
The context of EEG, electroencephalography, signal noise refers to any unwanted or irregular activity that can interfere with the measurement of electrical brain activity. There are four main types of noise in EEG. Uniform white noise. This type of noise is characterized by a constant power spectrum across all frequencies. It is a random noise that is equally likely to occur at any frequency. In EEG, uniform white noise can appear as a constant background noise that does not change with frequency. Gaussian white noise. This type of noise is characterized by a power spectrum that decreases with increasing frequency. It is a random noise that is more likely to occur at low frequencies than at high frequencies. In EEG, Gaussian white noise can appear as low-frequency noise that does not change with frequency. Periodic noise. This type of noise is characterized by a power spectrum that is periodic, meaning it repeats at regular intervals. In EEG, periodic noise can occur when there is interference from external sources, such as electrical equipment or power lines. Inverse F noise. This type of noise is characterized by a power spectrum that is the inverse of the frequency. In EEG, inverse F noise can occur when there is interference from internal sources, such as muscle activity or brain activity. It is important to note that these types of noise are not mutually exclusive and can occur together in EEG signals. Reducing noise in EEG signals is an important task in the processing and analysis of EEG data. Techniques such as filtering, artifact rejection, and signal averaging can be used to reduce noise in EEG signals and improve the quality of the data.
Okay, this much better. I wanted to do just paragraph 4. Oops. And then together for the other types.
Inverse F noise, also known as 1/F noise, is a type of noise that is characterized by a power spectrum that decreases with increasing frequency. In other words, the power of the noise is inversely proportional to the frequency of the signal. In EEG signals, inverse F noise can occur due to a variety of factors, including electrical currents in the brain, muscle activity, and other external sources of interference. Inverse F noise is typically more prominent at lower frequencies and becomes progressively weaker at higher frequencies. This type of noise.
Hopefully the electrical currents in the brain go away when we regenerate.
Noise can be challenging to remove from EEG signals because it is often difficult to distinguish from the underlying brain activity. Inverse F noise can have a significant impact on the accuracy of EEG signal analysis. It can make it difficult to identify and separate different types of brain activity, and it can also contribute to the production of artifacts in the signal. To minimize the impact of inverse F noise on EEG signals, a variety of techniques can be used, including filtering, artifact rejection, and signal averaging. These techniques can help to reduce the noise in the signal. Inverse F noise in EEG, electroencephalography, signals refers to a type of noise that is characterized by a power spectrum that is the inverse of the frequency. This means that the power of the noise decreases with increasing frequency. Inverse F noise is caused by a variety of factors, including muscle activity, brain activity, and external sources of interference. It is often difficult to separate from other types of noise in EEG signals, and it can be challenging to reduce or remove completely. Inverse F noise can have a negative impact on the analysis of EEG data, as it can obscure or distort the underlying brain activity. To reduce the impact of inverse F noise in EEG signals, a variety of techniques can be used, including filtering, artifact rejection, and signal averaging. Filtering is a common technique used to reduce inverse F noise in EEG signals. However, it can also remove some of the underlying brain activity, so it must be used with caution. Artifact rejection is another technique that can be used to remove artifacts, including inverse F noise, from EEG signals. Signal averaging is a technique that involves combining multiple EEG trials to improve the signal-to-noise ratio. Overall, reducing inverse F noise in EEG signals is an important task in the processing and analysis of EEG data.
Well, this is better than the previous one because it didn't have that electrical activity in the brain thingy. But You can change the prompt and it will just add it in, anything you want.
Inverse F noise in EEG, electroencephalography, signals can be similar to spontaneous EEG activity, which refers to the random and spontaneous fluctuations of electric potential that occur in the brain when it is not engaged in a specific task. In fact, inverse F noise can sometimes be mistaken for spontaneous EEG activity, especially if it occurs at frequencies that are similar to those of the spontaneous EEG. One way to distinguish between inverse F noise and spontaneous EEG activity is to look at the spectral power of the noise. Inverse F noise typically has a higher spectral power at low frequencies than at high frequencies, whereas spontaneous EEG activity tends to have a more uniform spectral power across frequencies. Another way to distinguish between the two is to look at the temporal patterns of the noise. Inverse F noise tends to have a more random and unpredictable temporal pattern, whereas spontaneous EEG activity tends to have a more regular and organized temporal pattern. In general, inverse F noise can have a negative impact on the analysis of EEG data, as it can obscure or distort the underlying brain activity. Spontaneous EEG activity, on the other hand, can provide important information about the underlying neural activity and can be used to study a variety of brain functions, including attention, memory, and sleep. Overall, it is important to carefully evaluate the spectral and temporal characteristics of EEG signals to distinguish between inverse F noise and spontaneous EEG activity, and to use appropriate techniques.
No, it's no good, no good. It's going places. Don't think it's accurate at all.
Inverse F noise and spontaneous EEG, electroencephalography, are two different types of signals that can be recorded during an EEG experiment. Inverse F noise refers to a type of noise that is characterized by a power spectrum that is the inverse of the frequency. This means that the power of the noise decreases with increasing frequency. Inverse F noise is often caused by muscle activity, brain activity, or external sources of interference and can have a negative impact on the analysis of EEG data. Spontaneous EEG activity, on the other hand, refers to the random and spontaneous fluctuations of electric potential that occur in the brain when it is not engaged in a specific task. Spontaneous EEG activity can provide important information about the underlying neural activity and can be used to study a variety of brain functions, including attention, memory, and sleep. While inverse F noise and spontaneous EEG activity can be similar in some respects, they are also distinct and can be distinguished based on their spectral and temporal characteristics. Inverse F noise tends to have a higher spectral power at low frequencies than at high frequencies, whereas spontaneous EEG activity tends to have a more uniform spectral power across frequencies. Inverse F noise also tends to have a more random and unpredictable temporal pattern, whereas spontaneous EEG activity tends to have a more regular and organized temporal pattern. Overall, it is important to carefully evaluate the spectral and temporal characteristics of EEG signals to distinguish between inverse F noise and spontaneous EEG activity, and to use appropriate techniques to reduce or remove the noise when necessary.
It's pretty bad. That's a good sentence. What was that?
The presence of inverse F noise in spontaneous EEG can have both positive and negative impacts on the analysis of brain activity. On one hand, the statistical property of the noise can make it more difficult to separate the desired brain signals from noise sources or to use statistical methods for data analysis. On the other hand, the presence of inverse F noise can provide additional information about the underlying neural activity and can be used as a source of data for further analysis. Inverse F noise is one of several types of noise that can occur in EEG signals, and it is important to take into account the specific characteristics of the noise when analyzing EEG data. Techniques such as filtering, artifact rejection, and signal averaging can be used to reduce or remove the noise, and data analysis methods such as spectral analysis and statistical methods can be used to extract meaningful information from the EEG signals. Overall, the presence of inverse F noise in spontaneous EEG signals can provide important information about the underlying neural activity and can be used to study a variety of brain functions. By carefully evaluating the spectral and temporal characteristics of the EEG signals and using appropriate techniques for data analysis, researchers can gain a better understanding of brain activity.
No. Don't need power spectral density. Oh, wait a second, we do.
Noise is a common issue in EEG signals that can degrade signal quality and obscure meaningful information. There are four main types of noise in EEG signals: uniform white noise, Gaussian white noise, periodic noise, and inverse F noise. Each type of noise has a distinct power spectrum and can arise from different sources, such as external or internal factors. To reduce noise and enhance signal quality, various signal processing techniques can be employed, including filtering methods, artifact rejection algorithms, and signal averaging techniques.
Yeah, this will be published soon with all the changes with the text and some other updates. And I'll see you next time or the next tool. Don't forget to subscribe. Bye.